All right, hello everybody. I heard hi Todd, I love that. Okay, so before we really dive into this, I've been told to point out the Discord channel, so I've already put some things out there. If you have questions during or after, I'll try to address them. Otherwise, there's my contact information there. I also put out a bunch of stickers and business cards on the way in, so if you didn't see those, feel free to grab them. Okay, this talk is hostile JavaScript, attacking and defending the browser. And this is a bit new for me because I usually talk about like monitoring or observability or debugging. And so this is really my first steps into the security world. And it's a bit of a story of how I figured out that this was such a big problem. My name is Todd Gardner. I was actually here at StirTrek in 2019, and it's really cool to be back after all of the craziness of the last couple of years. You might know me from various things. I build various things with software. I built a service called Track.js, JavaScript error monitoring. Lately, I work on a thing called request metrics. I also did PubConf. I've done a few podcasts, lots of other stuff. So here's what we're going to talk about today. First, we're going to talk about ways that we can attack our users or our system or the browsers with JavaScript. What kinds of things can I do, nasty things can I do with JavaScript? Then we're going to talk about ways that I could get that nasty, malicious JavaScript into browsers. Ways like various vectors. Then, once I've thoroughly scared you, we're going to talk about some ways that we could go about defending against these. Now, I firmly believe in the rule of 2 feet with conferences. So if this isn't what you expected and you're regretting and you really want to go see one of the other talks, feel free to get up and go to it. Don't sit here and not get out of this event what you wanted. I will only be a little bit upset and cry later. Sound good? Yeah. Great. All right, let's get going. So to talk about JavaScript and how to attack it, I needed a website. So I went and built a website. And I grew up in an era of GeoCities. Did anybody here have a GeoCities website? Yes, I love that. I've gone to events and I feel like I'm the oldest person there and they have no idea what GeoCities is. GeoCities was this early internet thing that we could go and make websites, and it had awesome graphics like this super pixelated brick background, and we used really obnoxious fonts and bright colors and all kinds of things. And no matter how long a website was in there, it was always under construction. There was no finished GeoCities sites. And what we really came here for was to put fun GIFs on, like the dancing baby, which was my favorite. And there was early analytics tools in the form of visitor counters, where it would just be a little thing that would tick up as new people visited your page. The dirty little secret is that you could start that number anywhere you wanted. So I could have it be at elite, I could have it be at 1 billion, I could have it change randomly as it goes. And because this is such an awesome website, I want to make some money on it, so I'm going to put some advertisements on it. Pizza Hut was one of the early innovators of online advertising. And to get this basic website online, I needed JavaScript. So just this simple stuff, I already had to bring in these JavaScript files. So I had my own JavaScript, my scripts.js file. I still like jQuery sometimes, so maybe I bring that in from some CDN. And then I have my cool analytics counter and a terrible ad bidder thing. And so, all right, I have 4 JavaScripts, 4 different domains that I'm loading JavaScript from. But this site obviously is going to do so well, so I went and hired some marketers. Is anybody here a marketer? I don't see any hands, so we can make fun of them. So marketers did what marketers do, and they put Google Tag Manager on the site, which if you're not familiar with is basically this nasty backdoor that lets them load whatever JavaScript they want with no code review or anything. So they did that, and now the website needed more things. So they put some more ads on the page. We needed to boost revenue, so some more things from Pizza Hut and early online auction things. And my analytics wasn't enough, or it wasn't right, it needed something else. So we needed some more analytics on the page. And now we have a bunch more JavaScript coming in the page that I didn't review, I didn't know that it was there. It just got loaded onto the page from Google Tag Manager. So now I have that Google Tag Manager tag, which obviously is going to bring in DoubleClick, Google's advertising engine, and some cool trackers from various different domains. I know you're all really excited about this website. So if you want to check it out and you happen to be lucky enough to have any signal, I bought geocities.website. And so that is where this is hosted. If you like QR codes, that is a QR code that sends you to GeoCities website. And so we're going to use that later. So let's get into this. How are we going to attack geocities.website with JavaScript? There's a couple of different ways that we could take advantage of our users or our system to do things for our own nefarious purposes. The first is by using their resources. So they have this supercomputer level of computing device in their pocket or on their desktop, and we can use their electricity and their computing devices to do things. So I could drop more ads on the page. I could drop my own ads on the page where I'm getting that bid revenue, which is kind of boring. Or I could mine my own cryptocurrency using their hardware with JavaScript. CoinImp is a cryptocurrency implementation that you can mine with JavaScript. And so this has been used maliciously to go into lots and lots and lots of pages and mine cryptocurrency from its unwitting visitors. So if you pick up your phone and you notice that it's like hot, and you're like, what is going on? Maybe one of those browser tabs is mining cryptocurrency. But visually, to the end user, if they didn't notice that their fans were on high or their phone was hot, they might not notice what the website looked like. Other than there might be some more obnoxious ads on the page. In this case, covering up the babies, which is the whole reason anybody came to the site. The second thing that we can do is we can turn, sorry, this echo is really throwing me off. The second thing we can do is we can compromise the user's intention. We can trick them into giving us more information. So if I wanted to get credentials, I could use JavaScript to just pop a modal, a login box. And maybe the user doesn't remember creating a username and passwords for this awesome geocities.website thing, but a lot of them is just going to frantically type in their username and password that they use for everything. And then I can capture it. And then I can use that username and password to try and log into their email, to their eBay, to their whatever else I think they used it for. Or I could go for something way more valuable and try and trick them into giving me like named credentials for like GitHub or Google or Stack Overflow or Facebook or whatever by putting these buttons that we've all been trained exactly what they do. And if you click on them and it brings up the little pop-up window to log in, are you going to look at the URL that just opened? Or if it looks like the Google window, you'll just type in your stuff. And so we can scrape those credentials. Collectively, though, that's kind of boring. Like, I'm sure many of you are aware of these exploits. It happens. It makes the attackers some amount of money to do those things, but it's kind of uninteresting. So let's talk about the interesting stuff. Let's talk about stealing data, both the user's data and your company's data. And that's usually done with one of two strategies on the malicious JavaScript, either monkey patching or key logging. And I'm going to show you an example of each. How many of you here are JavaScript developers? Cool, yes. How many of you are security, pen testers, that sort of thing? Cool. Usually, when I show this to non-JavaScript developer security people, they kind of flip out if they didn't know this was the thing. Monkey patching is our way in JavaScript that I can change what a function does, even a base native level function of the browser that you thought was safe and reliable and it did what you thought it did. In this case, I am monkey patching fetch, the main modern way that we send and receive data from APIs. I am changing it to intercept and copy all the data. So I grab a copy of self.fetch, the main fetch option. I name it in my ofetch variable, and then I just redefine it to be my own thing. And my own thing calls the actual fetch function because we don't want it to not look like it's working if we're attacking somebody. And in addition to sending the data to where you want to send data to, we also send it to my own domain, my x0x0day.br/clone. I just take a copy of all of the headers, all of the data payload, everything that you have, and I send it off to my own stuff. And so that would basically look like I have a user, they're interacting with the app, they're doing something really interesting and novel, like posting up a form with their name and email and credit card number or whatever, and I'm silently just taking copies of every single thing that they do. Now, that's pretty cool. It can grab a lot of different kinds of data that way, but it also generates a lot of noise. There's a lot of payloads to try and figure out, like, what is the shape of this? So if I've been attacking a website for days and days and days, or months and months and months, understanding the data set that I capture can be kind of hard. And so there's a far simpler approach that's a little bit easier for an attacker to digest with a simple keylogger. So this just lists, that echo, it's killing me. I'm like stumbling over the end of my sentences. A simple keylogger, we're just listening at the top level for every time the user does a keystroke. And when they do, we just send those keys off to our endpoint. Obviously, a real attacker would have something a little bit more advanced than this. It would probably batch things up, and this would be really obfuscated and coded, and you wouldn't really see that this was a thing. But this is taking a copy of every keystroke and fetching it, like posting it off to x0x0day.br/keys. And so as the user is on, say, a checkout form and they're filling out their credit card number, we would be posting off credit card strings like 424242424242, which is one of Stripe's credit card test numbers if you do that sort of stuff. So we just get these long strings of user data, which we can really easy just run regular expression matchers on to find things like credit card numbers, social security numbers, mailing addresses, email addresses, words called password, that sort of thing. And this is not at all theoretical. How many of you have heard of MageCart? No, I didn't see. I mean, I'm blinded by lights, but I don't see any hands. MageCart is the marketing-friendly name that some security researchers gave of a widespread collective attack that has been happening on the internet since like 2014, 2015, somewhere in there, that we don't know if it's one organization or several organizations, but collectively, they made it because somebody gave them a name and made them a logo and talks about them like that. So that's really making it as an online criminal, I think. MageCart is a keylogger. It exploits various vulnerabilities that we'll talk about in the next section to put these keyloggers onto various websites that listen specifically for being on a credit card form. And when they are, they start logging everything. Now, it collectively just reads and reads and reads for months, because as soon as they start charging them, the credit card numbers can figure out who the common merchant of all of these things are and shut it down. So usually when these vulnerabilities happen, they've been happening for months and months before anybody becomes the wiser, which can amount for a large amount of money. Since 2015, over 70,000 stores have been found to have MageCart on them. And you might have heard of like some big notable ones like British Airways, Ticketmaster, the UK government, like really big, well-known sites that we would expect to have crackerjack security practices got screwed over by MageCart and lost first tens, hundreds of millions of dollars in fees and fines from the credit card companies that charge them to replace every credit card that got stolen, and then regulators that come down on them for things like GDPR and user privacy legislation and slap them with more fines. So both of those methods are passive attacks. So the ability for an attacker to get something in your system and just quietly listen for all of the user's data and exploit it in one big go sometime down the road. But we could also use JavaScript for a more active attack to go after you, the company. We could get access to a live user's session. And instead of installing a keylogger or cloning their network requests, we could interact through that JavaScript and essentially session jack them and use their active web session to crawl your API and pull whatever data that user has access to, or perform whatever actions that user would have the ability to do. In this way, if you are a high-value company, a high-value target, not only do you have to worry about the data that actually has gone to the browser, but any data that the browser has the potential to access. So if a token or if a session token can be used to crawl an API, it potentially will be used. This isn't theoretical either. There is a project online called Beef, the Browser Exploitation Framework, that essentially lets penetration testers and various other security researchers, never malicious actors, do this. Using various exploits, it puts a live connection into a browser, and then you can just interact with it. You can discover the APIs that they've called, you can make those calls yourself, and it uses the remote exploited browser as a tunnel for you to do whatever you want. Are you scared? Because as I've played with this, I got scared. But then I was reassured. I'm like, yeah, but who's actually going to, put somebody else's JavaScript in my page? Like, I'm too good of a developer for that. That's not going to happen to me. So let's talk about some ways that JavaScript can get injected into these sites. For completeness, I want to talk about the boring ways too. Because obviously, if you can exploit a server or a cloud service or whatever using any of the common code injection or remote execution exploits, you can tell that server to, add my JavaScript file to the page too. Lots of research there, lots of things around protecting your browser, running your patches, having appropriate firewalls, all those things. I want to talk about the client though. And the most common way things happen in the client is through cross-site scripting. All of the JavaScript developers in the room know exactly what I'm talking about, where you have annoying QA and security testers pasting this string into every input of my website, waiting to see if an alert pops up. And it's not just about annoying users with like alert, alert, Todd's cool, alert, alert, your site is vulnerable. No, if I can do this, I could use that string of JavaScript to load one of the malicious things. I could load a bit of JavaScript that does MageCart. I could load an exploit of the browser exploitation framework of Beef, and then do an active session jacking attack. Oh. Yeah. So it's more than just these annoying things. And cross-site scripting isn't just like this kind of fringe problem. As long as there has been a top 10 list of most exploited things on the internet, the OWASP top 10 list, this has been on it. It has never not been on it. There's no real sign that it won't be on it 5 years from now. Like, we don't have a good, reliable, 100% solution to this other than we constantly test, we make secure by default, we do all of those things, and this still happens. A newer and potentially scarier exploit that has been emerging in the last couple of years is supply chain attacks. Has anybody here heard of supply chain attacks? Yeah, there was a couple of like big notable ones that made the news through SolarWinds and Log4j, and there's a third one that I'm not remembering at the moment, where these big common vendors had some exploit that could be used to like hack into your system, and those things were everywhere. This can also take the form of a much more active supply chain attack. So this string right here, for the JavaScript developers in the room, npm install something. In this case, I'm building a little npm app, or I'm building a JavaScript app using Ionic. And I want a cool icon pack to use in my thing. And so I find this package, and I just say, great, npm install this thing. I have my icons. Everything is gravy. I move on with my day. What I don't know is that this had MageCart in it. This is a part of a large-scale exploit that was called icon burst, where attackers created common typo and common unclaimed name packages out on NPM that do viable, valuable things that people really wanted to do, and in addition had a highly encoded version of a keylogger or some other exploit right in it, where it would wait for credit card forms and steal that data. And this isn't like a one-time thing or one package that we found and fixed, and this isn't a thing. Here's a list of packages as of, I don't know, a couple of weeks ago when I made this, that are active on NPM right now and contain MageCart. and how many times they'd been downloaded in the last 24 hours, which is a lot. And if you look at those don't look scary, right? I don't know if you can see them, but it's things like Ionic Icon, Ionic ICO, Ajax lib, icon package, unbreakable, like things like words that seem totally viable to end up in a game of like JS library or drink. Some of you have played that. So this is an ongoing problem because many of us, if we're starting a project and we go npm install React, and now 100,000 lines of code are just downloaded into our node modules folder, and we all stop the project at that point and conduct a thorough code review for the next 3 to 4 weeks, where we look through all of that code and make sure that none of React or React's dependencies or their dependencies or any way down inadvertently contains something nasty. No, of course we don't. We don't have time for that. None of us have time. It's not really part of the web dev culture. We have so much because everything depends on everything else, and we just trust that everybody's being a good actor. If you're in a large-scale organization, there are some solutions to this, some active scanning, some like proxy levels where you don't actually talk to NPM, you talk to your own thing that's already been vetted, and those are the only packages that work. And yeah, that's secure. It's painful to work in some of those environments because you don't feel like you can get anything done because none of the packages you need have been vetted yet. So for 99% of organizations, we just trust that everything is good and move on. So what if there was another vector? So the first two around getting code that the developer didn't intend to put in their app. What if we had a vector that they intended to put in their app? What if we built a service or a bit of JavaScript or a popular library that we thought was useful, and we convinced developers that it was useful, and we just got them to copy that and install it on their website? Well, I did that. I built a service called Track.js, which is an error monitoring tool. And as part of the install process of that, I asked the user to take this JavaScript, which is just, here's something from cdn.trackjs.com, my own place. Put this tag on your page and load it. And for doing that, I'm going to give you all of these valuable things. And lots, like thousands and thousands of people did that. The trouble is that lots of those people ended up not ever paying me. They decided that, like, hey, for whatever reason, this isn't right. But they never took it off their page. And so years and years later, they are still loading my JavaScript on their page, and I'm just throwing away the data that they send me, but they're loading arbitrary JavaScript that I could change at any time from a remote target. And these are big companies that do this. As of a couple of weeks ago, the sun.co.uk was still loading Track.js JavaScript. And they never subscribed, and it's been on there for like 6 years. Now, if I was a bad actor, I could do nasty things. I could put CoinImp in there and start mining my own cryptocurrency off of all of those visitors. I could put MageCart. I could do all kinds of things. And I know some of you are thinking, yeah, but you're reaching, Todd. That's not really a vector. There's a bunch of legal things that say I can't do that, I won't do that. You'll be able to sue me to oblivion if I do that. There's all those sort of things. But you have to think about how those scripts and ownership can change over time. Because ownership can change. If you depend on some open source library that doesn't make any money, but you've depended on it and you just load it from their source, and then one day Mary, who's been working on this library in her basement, decides, like, screw it, I'm gonna get paid, like, I'm gonna sell this to somebody online, and they're gonna take over it, and now they drop MageCart in. Now it's not Mary who even owns it anymore. It's some weird Russian consortium that you don't have any idea and you can't go after, but you are blindly just loading the JavaScript from their remote source. So that's weird. But as long as that doesn't change, there's a bunch of legal protections that we can use, especially if you're dealing with an actual corporation and not just an open source package that says they can't do those sort of things. And so maybe that's not the worst vector. The worst vector would be if, like, you loaded a bit of JavaScript that had a few attributes to it. That JavaScript you loaded was dynamic. It was expected to change over time, and its behavior would do different things. And if it was anonymous, like you didn't log in, like there was, anybody could get access to it, and if it gave the user any ability to do remote control. Well, turns out I built one of those too. A couple of years ago, I thought, hey, this Track.js thing I was doing is really cool, but what if we could do it in, like, real time? So the thing that was unique about Track.js was that it not only showed you the error, but it showed you, like, here's what the user clicked on, and the network events, and push state events, and all kinds of things, so that you could recreate the story. But we heard from people who were trying to debug on, like, hard-to-use devices, like set-top boxes running an Android thing, where, like, they would have a weird bug, but they couldn't recreate it, and you couldn't attach a debugger to it. And we thought, hey, we could build something to do that. Let's take Track.js and put it in a way that, like, it streams those events in real time. And what if we could send commands to ask for more data? And in a debugging sense of the word, that's really valuable. It helped a lot of people. But unfortunately, a lot of people didn't really understand the security aspects of this. So let's see, I have a video version of this demo if this crashes and burns, but let's give this a try. So I put remote.js in geocities.website that gives me a backdoor into any of the visitors' sites. Now, in this case, don't be worried. The worst thing I can do is mess up your experience on geocities.website, which isn't all that bad. But I want to show this off. So if you have the ability to get on the internet right now, head out to geocities.website, and there's a little form in it where you can say, what's your favorite part of the old internet? And we'll do a little demonstration, hopefully. All right, so this is remotejs.com. And so when somebody was to come in here and start something, they'd hit Start Debugging, and it would generate this little snippet of JavaScript, which was meant from a debugging context. You put this in your site, and now you can connect to those sessions. But the total extent of security on this is this magic string that gets developed. In this case, it was just a GUID. And anybody who knows this GUID can connect to those users. But this GUID is readable in the source code of your web page. Now, on geocities.website, that channel code is just GeoCities website. So here I can see everybody who is connected currently. We have some mobile Safari users, some Chrome users. I know we have 2 different rooms here, so we're going to see if we get lucky and see who's here. So I'm going to connect to this Chrome 113 on Android, and let's take a screenshot of what their browser looks like right now. And hopefully this works. While that's loading over this unstable internet connection, we see that this was, hey, there we go. So here's what it looks like. It's obviously very big. They tried to put in a marquee hello world, which we did not accept. Now, who is this? Is this person in the room? Hey, how you doing? Thank you for playing. So we're gonna interact here. You're going to be my puppet, because you'll see here, I can see that they typed 9 characters into this text area, then they clicked on the submit button. But I could ask more questions. This is just like I have Chrome DevTools open on his browser. So I could look at navigator.useragent, and eventually it'll come back and it says Mozilla 5, Android 13, Pixel 6 Pro. I can see all that. I could also send things like alerts, like, hey, dude. I think I spelled that wrong. There we go. There's a little inline ad for Track.js. Did the alert pop up? It did. Or I could just change where he is. So I could say window.location equals HTTPS to be secure, requestmetrics.com. And I can send him off to a different website. Thanks for playing. So I could do this with any of these users. Now, again, the point of this was we have a hard to debug issue. I want to see what's happening as the user's clicking through. I want to interrogate the state of the object, and it's super valuable for all that. But if I was to take this and just put it in production, that's kind of scary, right? But all kinds of people did, and I keep shutting them down. But it's really hard to stop it without just killing the whole service. But we've had healthcare sites with patient health records put this on their site, which this is, you'd have to look it up specifically, but I'm pretty sure this is not HIPAA compliant. That demo worked great. I did not have to play my video. So collectively, between what I learned building Track.js and what I learned building Remote.js, and what I continue to learn with my new thing, request metrics, is that most teams, most people have no idea what JavaScript is actually on their site. They don't know. They have an idea. They could, if somebody came to them and said, give me a bill of materials of your software, they would dump their package JSON or whatever and say, here's the things that are in there. But it doesn't include any direct script tags or side-loaded things or Google Tag Manager or any of the hundreds and hundreds of things that we just drop on our page. And that is scary. The fact that this issue isn't weird and rare. This is an issue that 90% of the teams I talk to have this problem and could not produce a set of, this is the JavaScript that runs on everybody's browser. And the reason why that gets even scarier is because those exploits that we've been talking about have gotten so big that compliance and regulation is starting to mandate things around how we deal with it. The PCI DSS group, the one that governs credit card transactions, as of 2025, which, things are slow because of bureaucracy, As of 2025, it specifically names MageCart because it has cost them so much money that you need to be able, if you take a credit card, the page that takes a credit card needs to either have no JavaScript on it, like that's gonna happen, or you need to be able to produce a definitive list of all the JavaScript that runs on it at any time. And we can't really do that. There's not really good ways to do that. If you have any sort of European coverage, the GDPR has some language in there that the courts are starting to interpret around this sort of thing, where you have to take reasonable precautions to protect user data and know where that data is flowing. And it's conceivable to interpret that you need to know all of the JavaScript that's running and where it sent that user data to. So these are big problems that are coming that we don't really, as an industry, have good solutions to, but we all just kind of pretend it's fine. So let's get into the final bit here of defending the browser. I like to start each of these sections with the common sense but boring and kind of unachievable advice of you should review your dependencies, but you're not gonna. This has come about with a bunch of legislation and security policies and practices around coming up with a software bill of materials, which is an attempt to solve this problem through documentation and in process. But unfortunately, I don't think that's really going to work on the web, given our culture of how we bring in lots of libraries and we sideload things. And it's just unachievable to really produce this at build time rather than understanding what's happening at runtime. So how would we do that? Well, there is a well-established standard in browsers called the Content Security Policy, which was meant to address exactly this problem. It was a set of HTTP header rules. So you put it in a header when the document gets served so that JavaScript can't mess with it. And it's a set of rules that you say, here's where I will trust to run JavaScript from. Here's where I trust to send data to. Here's my definitive set of rules. And in theory, that looks like this. We say, hey, I want to load stuff from myself. I don't want to load it from anywhere else. Stop it. And that sounds great. Like, security people will be like, that's what we want. Unfortunately, when you put it in practice of the web, it ends up looking like this, where we start with like secure by default. But then we need Google Tag Manager, and we're going to need some tracking pixels, and we're going to need the CDN, and this, and that, and the other thing, and 21 more things. Oh, and we're going to load some scripts from Track.js. Oh, and I want to load images from anywhere. And this list just gets bigger and bigger and bigger, and every one of these becomes not just trusting the specific thing, but that thing will never change to do something bad later. Additionally, this has the complication that just changing headers in a lot of web platforms is hard. It's not a very common dynamic thing that we do, and so it ends up creating a lot of process bureaucracy in organizations. Now, if you have a site that's highly sensitive, if you're in banking, if you're in government, healthcare, that sort of thing, you should totally use content security policy. But you probably won't, because it's really difficult on the human side of process. Now, if you want to do this, there's a great tool run by a friend of mine called Report URI. It can help you put together your content security policy. Here's what it should be. And it can receive all the reports and tell you a bunch of interesting things about that data. Unfortunately, due to the technological and human factors in this, as of today, less than 10% of domains use a content secure policy. And this has been around for quite some time, like 8 or 9 or 10 years. This just isn't widely adopted because of those problems. There's another technology that aims to solve some of this, specifically the problem where you're pointing at some JavaScript on a CDN, and so you're trusting whoever owns the other side of that not to change it and mess with it. And so you could solve that by just taking that JavaScript and hosting it somewhere you control, but there's lots of cases where you can't do that due to the vendor's constraints or some other thing. And so if you want to protect that, sub-resource integrity is what that's for. And that looks like something like this. Here's a script tag that we're loading from example.com. And that vendor would hypothetically produce an integrity hash, this nasty string of characters that we would throw in that attribute. Then, when the browser goes and gets that JavaScript file, it would compare the hashes, and if it didn't match, it would not execute the JavaScript. And so you could guarantee that the vendor would not change the JavaScript out from under you. The trouble with that, and there's two. Well, the first trouble is that sometimes the vendors want to be able to change it, and that's why the situation is what it was to begin with. But the second thing is that it requires the CORS headers, the cross-origin resource sharing headers, which is why you have to decorate it with this cross-origin anonymous thing. And for those of you who are web developers in the room, when I said CORS, your blood pressure went up a little bit. I made this handy flowchart for debugging websites. Help, my website is broken. Is it DNS? No, it's CORS. It's one of those two things. CORS is really hard to get right, to troubleshoot. It changes in production for weird reasons. There's various proxies across the internet that strip CORS headers and cause things to not work. And the downside of all of that is that if the CORS headers don't work, all of your scripts just stop working. And so for that risk, this doesn't get wide adoption either, because we would rather our scripts work than that they're secure. And so it's a trade-off here of functionality versus security that is off. It's not reliable enough to be worth the overhead for most organizations. And so this whole situation sucks. We have scary problems. We have continuing vectors. We have some technologies to solve them, but the balance of utility and security of those things is off. And so they're not widely adopted. And so we collectively just kind of ignore that this is a problem. And we're kind of just waiting for one big security incident to happen that's going to change all of this. So I have been thinking about a better way to approach this. Can I break this stalemate and create a different way to look for these sort of issues? So if we start with geocities.website, I'm a JavaScript developer by practice. And I have this hammer called JavaScript. And I really like this hammer. It's my favorite hammer. I use this hammer to pound all the nails in my life. And so I have a JavaScript problem, and I'm going to solve it with more JavaScript, because that's what I want to do. So I'm going to take some JavaScript. Let's call it RMJS. I'm going to drop it on this page. So What that allows me to do is I can use a set of APIs and monkey patching and discover utilities that are available to me in the browser to discover what other JavaScript is running right now. And I can find my scripts.js, I can find my jQuery, I can find my counter, and I can find the stuff that's loaded at runtime, too. I can see, like, hey, here was stuff that was side-loaded from Google Tag Manager, like DoubleClick and Tracker and whatever. And I can figure out how it was loaded. I can see, hey, these things were script tags that actually came down from the browser or from the server. These are real. And these things were loaded with document write. These things came in via some dynamic mechanism. And I can look at where data is flowing. If we're the victim of a supply chain attack, all of the scripts on my page would look fine. They would be my scripts. It would be my bundle.js file. But data might be flowing to somewhere scary. So using those same sort of things, I can look at where data is flowing from your site. I can see that there are post events happening to copy the data. And I can even look inside of those payloads to say, hey, this contains things that I think are a name or an email address, or they match a credit card number, regex, or stuff like that. And so I've been working on how to do that for a while. Actually, 2 days ago, we shipped the first version of this, which is our JavaScript security report as part of request metrics, where we track all the domains, how long that domain has been referenced on your page, how old that domain is from whois records, how much data it's received, a bunch of other stuff. And this doesn't exist yet. This is just an idea in my head, but this is like a data exfiltration report that based on that same data that I can capture, I can list off things like you're receiving data or sending data off to Google Tag Manager, to Marketing Pixels, but there's also data going off to x0x0day.br, and that was only registered 63 days ago. That's weird. Now, I'm not stopping it from happening. This isn't like I'm not going to block and shut things down because then I'm losing that balance between security and utility. Because 9 times out of 10, x0.x0day.br is real. It's something that the marketing team needed or the developers wanted or whatever. But I should know about it. We should have a conversation of like, hey, this is a new thing. That's interesting. Did we mean to do that? And if we didn't, we can shut it down in hours instead of months. And I think that's a good trade-off. So that's what I've been working on and where my ideas have been going. I've been working on this thing called request metrics, which is client-side observability. We're matching up analytics and error monitoring and security monitoring and API monitoring and putting a cohesive picture together. And if you want to talk about that later, I'd love to talk about that later. So those were the 3 things. How to attack with JavaScript. We played with like crypto mining and monkey patching and key logging. We showed vectors, including the very cool remote.js, which feel free to use. It's totally up there and free and whatever. Don't put it in production. Please don't put it in production. And then some ways to defend. So if you're a high-risk organization, use content security policy. It is the way to protect your users. If that is too hard for your tech stack, your person process, maybe something that I'm working on can help. This was Hostile JavaScript. Thanks so much for coming. Again, I'll be on the Discord or up here if you just want to come talk to me. Feel free to grab some stickers or a business card or whatever on your way out. Thank you so much, and have a great day.